Welcome to another video of Engineering Economics, INEN 2373. In this video we're going to talk about how to select the planning horizon and issues surrounding this problem. The typical problem of planning horizons when we have projects that have different lives is how to select which one would be a fair position. The main idea is that projects that have a shorter life would have maybe not as good as a position to compete among other projects that have a longest life. So there's a trade-off between one or the other. Sometimes the strategy is to evaluate the planning horizon as the shortest life among all the projects. Sometimes the strategy is to select the planning horizon as the longest life among all the projects. Sometimes it is suggested, or as a common practice, to use the least common multiples of lives. And sometimes we just go with a policy by a company and that they usually have a standard length. Or maybe it could be the length of time for which investment is needed. And in some instances we can even take forever, considering perpetuities. So let's see a numerical example how this affects. Let's consider two projects, Project A and Project B. And Project A only has a projection for cash after an investment of $100 of receiving $150 in years 1 and 2, whereas Project B has initial investment of $200 and cash flows are projected to be $150 for years 1, 2, and 3. Naturally, if this is taken into consideration to have a planning horizon for 3, or we want to compare this using 3 years as a planning horizon, this would be equivalent to have 0 in this computation. So essentially that is not going to affect whether if it's 3 years or 2 years. This project will all have a present worth of 160.33. Whereas right now, if we take into consideration the 3 cash flows for Project B, the present worth would be 173.03. And if we only take into consideration 2 of the cash flows, then the present worth would be reduced to only 60.33, and therefore, naturally, we only take into consideration 2 years. We need to invest $100 more, and therefore it is more attractive just to invest in A. So that's why it's very important to give it a good solution. Alternatively, the suggestion could be, well, let's use the minimum common multiple of lives. So this has a natural life of 2 years, Project A, and Project B has a natural life of 3 years. So what we're going to do is we're going to repeat the stream of cash flows that we have. So what we're going to assume is in year 3 will be represented as year 1. So I have 150 and 150. But in order to get that, we need to make an investment the year before of $100, and then again for years 5 and 6 we also have 150 and 150, as long as we can invest negative $100 in the first repetition or second repetition of that particular year. So that's how the final cash flow profile for A would look like this. And naturally the common multiple of lives is 6, and we use this series of cash flows to compare the present worth as to compare it to the other. Now we can do the same thing for Project B, and with Project B what we would like to do, okay, this was Project A. Let's format it a little bit. Okay, and this is the final series of cash flows. Now for Project B, let's repeat this process. This process is going to be repeated only 2 times now, because we want to reach the sixth year. In order to get the last three $150, we need to invest $200 here, and then we create the cash flow profile for B. And that's how it would look like. And now we can compute the net present worth is the initial investment plus the net present value of rate 10%, and the cash flows are this, and the value of that is 402, whereas for project B it would be the value of the initial investment again plus the net present value of 10%, and we select the stream of cash flow starting at year 1, and that number is 303.03, and under the common multiple of lives we would select to do project A. So in this example, the common multiple of lives suggests for us to choose project A because the present worth would be 402. Compare that to present worth of 303 with the same methodology, t equals 6, or with the planning horizon of 6. Now, this idea of planning horizon sounds pretty practical, right? But pretty much it could become a little cumbersome. Let's consider that a project has, say, 7 years of life, the other one is 11 years of life, and the other one is 13 years of life. So now you have to come up with a minimum common multiple of lives, and since these are just prime numbers, then you would have 7 times 11 times 13. Your planning horizon is over 1,000 years, and that is just simply not practical. So from that perspective, many companies, what many companies do is to plan for a fixed policy, just as we mentioned before.